Today we will discuss how to find out the inverse of the matrix. In previous lecture we have studied about adjoint of the function or a matrix. Here we will discuss inverse by using adjoint of the matrix. Now here we will use formula A inverse is equal to 1 upon determinant of A into adjoint of A. It is written in a previous lecture also. Here is the formula which we will use to find out the inverse of the matrix. Now, first of all, I have to calculate determinant of this matrix. Write down the given matrix in the form of determinant sign. Now, expand this 3 by 3 determinant. Take 1 as here. Delete the row first. Delete the row, so our column first. Column and row both deleted. But you will get cos alpha, sine alpha minus cos alpha, 2 by 2 determinant. Cross multiplication take place, minus cos square alpha minus sine square alpha. I have written here. Take minus sign common. Cos square alpha plus sine square alpha is 1. 1 into minus 1, that is minus 1. Now determinant value is minus 1, which is not equal to 0. What it means? It is a non-singular matrix and its inverse exists, or you can say A inverse is defined. First of all, you must know whether inverse is defined or not. Here determinant value shows you whether the inverse is defined or not defined. Now for adjoint of A, you have to calculate cofactors. Capital A11, capital A12, A13, A21, A22, A23, and A31, A32, and A33. This is the adjoint of given matrix. I have transposed it and it is written as A11, A12, A13 in column wise. Because when rows becomes column, it means transpose take place. I have written here transposed matrix. Now put the values minus 1, 0, 0, minus 1, 0, and 0 here. 0 minus cos alpha minus sin alpha in the second column. These are the elements of the second row. After transpose, you have to write down in a second column. Third column elements are 0 minus sin alpha, cos alpha. Now this is the adjoint of matrix A. Now for the formula A inverse, you have to put the value of determinant value A and adjoint of A. You will get 1 upon 1 minus 1 and put the adjoint matrix here. Now when any matrix multiply by any scalar, it means that scalar will multiply all the elements of the matrix. It means when minus sign multiplied these elements, all the signs will be changed in the matrix. 1, 0, 0, 0 cos alpha, sin alpha, 0 sin alpha minus of cos alpha. This is a way to calculate the inverse of the matrix by using adjoint or by using cofactors of the given matrix. As you know, we have already studied in matrix chapter how to find out the inverse by using elementary transformation method. That was the one way to get the inverse. This is the second way to get the inverse. Now for the third way to get the inverse is the way by using equations. Now here we will use equation and to find the inverse. In question number 13 of this chapter, exercise 4.4, you can do it. Now take this question 13. Let the matrices A having elements 3, 1, minus 1, 2. Show that equation equal to 0. A square minus 5A plus 7I equal to 0 matrix. 0 means 0 matrix. Hence find the A inverse. Now this is a third way to get the inverse. Hence means what? Use this equation and find the inverse. Hence means in general, use the previous result and find out the next result. Now for calculation, you have to do multiplication here on A by A and put the values A square 5A plus 7I and get whether it is 0. Check it. Now when you multiply A by A, you will get 8, 5, minus 5, 3. Minus, when you multiply this A by 5, you will get 5 3 is 15, 5 minus 5 and 10. Plus 7 times of I. means 7 times of identity matrix. Identity matrix is 1 0 0 1. When you multiply by 7, 7 0 0 7. Sometimes in the equation, here only constant term will be written. You have to write down I yourself. You have to write down yourself. 7 means not 7 you have to add in the matrix. You have to put 7 into I and multiply that I matrix with the number. You will get matrix and do the question accordingly. Now simplify these three matrices. You will get what? 8 minus 15 plus 7. You will get 0. As same all elements becomes 0. It means this equation gives you a 0 matrix. First part of the question is proved. Equation gives you 0 matrix. Now next part is to find A inverse by using equation. I have here cleared that. What's the meaning of hence? Hence means by using previous result, find next. So by using equation, you have to find out the A inverse. Sometimes students use cofactor method, which I have given in a previous question, and that gives you no marks for that. If it is given that, hence it means you have to use the previous one result, then find the inverse. It means it is compulsory to use this equation to find out the inverse. Now what is the way to get inverse from this equation? A square minus 5a plus 7i equal to 0. It is given to you. Multiplying both sides this equation by A inverse. In matrix, two type of multiplications are there: pre-multiplication and post-multiplication. Here I have written post-multiplication take place. It means you have to multiply from the right hand side. A into A is here. When you multiply by A inverse, this comes out at last A inverse. 5 into A inverse minus 7i into A inverse. If I multiply, pre-multiply, then it becomes A inverse into A, like this. A inverse into A, and here A inverse into I. But I have written here post multiplication. That's why I written here at last A inverse in each term. Now use next property. A into A inverse gives you identity matrix. This is a property, and identity matrix is equal to A. Now put these two properties here. What you will get? A into A inverse is I. A into A inverse is I, and I into A is A. A is here A inverse. Now when you calculate A inverse, you will get, shift the minus sign here and 7 here, 1 upon 7, and change the sign of this. This comes out 5i minus A. Now you have to solve 1/7 of 5i minus A. It means 5 times of identity matrix minus given A matrix. I have written here 5 times of the identity matrix is 5 0 0 5, and A is the matrix 3 1 minus 1 2. Subtract these matrices and 1/7 put outside of the matrix. You can multiply this matrix by 1/7, or you can write as it is 1 upon 7 times of the matrix 2 minus 1 1 3. This is the inverse of the matrix by using equations. Now here I will give you an idea for the cubic equation to find out the inverse by using this. Now to find inverse from cubic equation, here what you have to do, same procedure will be applied. No need to confuse. Here equation is given. It is a question number 15. I am giving just hint to you how to find out the inverse. Before this you have to verify it. The verification means left hand side solution is equal to 0 matrix. After that you have to find out the inverse by using this concept. Now multiplying, post multiplication by A inverse take place. A inverse, each and every term multiplied by A inverse. Now A cube can be written as A square into A square written as A into A, and A into A inverse equal to I, and I into A is equal to A. Here A is A inverse. Now this A into A inverse comes out I. 6A into A inverse, this is I. Put the properties value and you will get what? 11 times of A inverse is equal to minus A square I plus 6AI minus 5I. Put, transpose these three terms into the right hand side. What you will get? A inverse is equal to minus 1 upon 11 A square minus 6A plus 5I. You have taken minus sign common. That's why here is minus 1 upon 11. Now you have to just put the value of A square, 6 times of A, and 5I. simplify this equation, and you will get a new matrix. Divide this matrix by minus of 11. You will get the A inverse. No need to find out cofactors. Just by using equations, you can find the inverse. Do it here on. Now for the next, I will discuss here a few examples of exercise 4.5. First example is example number 24. A matrix is given to you. You have to verify A into adjoint of A is equal to determinant of A into I and find A inverse. First of all, you have to check what is the determinant value. Take 1, delete first row, first column, you will get 4 4s are 16 minus 9. For minus 3, delete second column, first row, 4 minus 3. And for 3, delete third column and first row, what you will get 3 minus 4. Here I have written here. Simplify it, you will get 1, and 1 is not equal to 0. It means A inverse exists. What it means 1 not equal to 0? It means matrix is the non-singular matrix. If matrix is non-singular, only then you can find out the inverse of the matrix. Now here, for inverse, you have to calculate adjoint of the matrix. Adjoint of the matrix can be calculated by using cofactors. You have to calculate cofactors. Here I have written cofactors. Put the cofactors and transpose them. It is already transposed. All the elements which will be in a row, A11, A12, A13, those are written in a column. It means transpose already take place. 7 minus 1 minus 1, minus 3, 1, 0, minus 3, 0 and 1. Here 0 is written. Now you have to find out A into adjoint of A. Multiply A by adjoint of A matrix. For this multiplication, what you will do? Take first row, first column, you will get first element. First row, second column, you will get second element. First row, third column, you will get third element. And you can do the multiplication, whole multiplication. What you will get? You will get a identity matrix 1 0 0 0 1 0 0 0 1. Okay, this is noted by I. So what? A into adjoint of A is equal to determinant of A into I, because this matrix can be written as 1 into the matrix. 1 is the determinant value into I is the identity matrix. Now to find out A inverse, you have to put the value of determinant of A and adjoint of A. Determinant value is 1 and adjoint is this one. It means 1 multiplied by this matrix, you will get the same matrix. It means this is the inverse of the given matrix. Now next property, which is very important, AB whole inverse is equal to B inverse into A inverse. You have to prove it, both sides are equal. Now first of all, for the left hand side, multiply A and B. Multiplication take place, you will get minus 1 5, 5 minus 14. Now this is the matrix whose inverse you have to find out. AB whole inverse. It means you have to find out the determinant value of this statement. Minus 14 into minus 1, 14. 14 minus 25, that is minus 11 is not equal to 0. Inverse exists. AB whole inverse formula will be what? 1 upon determinant value of the matrix. Matrix is AB. AB write down here. Adjoint of AB. Now for the 2 by 2, we have already studied. You can calculate 2 by 2 matrix adjoint orally. What you have to do? Interchange these two elements. Minus 14, minus 1. And change the sign of these two elements. 5, 5, minus 5, minus 5. Now it becomes the adjoint of AB. And it is divided by determinant value. You will get here. Take this minus sign in the matrix. Change the sign of the matrix. You will get 1 upon 11, 14, 5, 5 and 1. Now for the next right hand side, you have to calculate both B inverse and A inverse. For A inverse, 1 upon determinant value of A. Here determinant value of A you can calculate. Minus 8 minus 3 minus 11, that is not equal to 0. B 3 minus of 2, that is 1. 1 is not equal to 0. It means both inverse are existed. and can be calculated or are defined. A inverse will be equal to minus 1 upon 11, and what you have to do, verbally you can do it, interchange the place of these two elements and change the sign of the element 3 and 1. Same is done here. For the B inverse also same is done. Now next is what? You have to multiply B inverse by A inverse. Put first B inverse, then A inverse and multiply them. You will get the right hand side. Multiply them, you will get this statement, and left and right both sides are equal. Now example number 25 is done. Example number 26 is same which we have done earlier. Let's do again. Here a matrix A is given to you. A square minus 4A plus I equal to 0. You have to show it. This is 0 matrix. This O is what? 0 matrix. I is the matrix. You have to take 2 by 2 matrix. And using this equation, find A inverse. In the previous example, question, I have written using this equation in the place of this, I have written hence word. Hence and using this equation, both are having same sense. So for the question, you have to first prove or show that this equation is equal to 0 matrix. Multiply A to A, you will get A square. Put the value of A square, minus 4 times of A, plus I, simplify it, 7 minus 8 plus 1, 0, 0, 0, all elements you will get 0. 0 matrix will be there. Now to get inverse from the equation, post multiplication by A inverse take place, multiplying this equation by A inverse. Here it is written here A square is as A into A minus 4 into A. Shifted this I to the minus I and multiplying by A inverse. Put the properties. A into A inverse is equal to I, and I into A is equal to A as it is. And you will get what? A inverse will be equal to AI minus 4I. Now what you have to do? AI into A into I is equal to A. It means just you have to put here A into I. That becomes equal to 4004 minus 2312, or you can put 4I, yes, simplified, 4 minus 2, 2, 0 minus 3 is minus 3, 0 minus 1 is minus 1, 4 minus 2 is 2. Now, this is a way to get the inverse by using equations. Now, do exercise 4.5, complete it and send queries in your on WhatsApp, or you can send the queries in a comment box. Have a nice day. Thank you. Thank you very much.